I want to introduce you guys to the people that are behind Dp.review, and that's Barney Britton and Rishi Sanyal. They're going to be leading this discussion this morning. So you guys, I'm going to leave it to you.
Thanks,
Let's
Jim.
have some fun. Thanks.
Right, yeah, I'm Barney, Dp.review, and this is my colleague Rishi on the other end here, and we're hosting this first panel segment. Thank you for joining us. This segment is going to be on changing the definition of photography. Specifically, that's technologies emerging now, which have the potential to change how we think about what still photography means, and how the boundary between video and still photography may end up changing. So I'm going to introduce the group, and let's start with Rishi on the end.
I'm Rishi, I'm scientific editor at Dp.review, and we're really glad to have you here today. I'll pass it over to Ariel.
Ariel Brownstein, I'm a pleasure to be here. I'm the Chief Product Officer at Lytro.
I'm Matt Frazier. I'm the National Training Manager for Lumix and Imaging Products for Panasonic.
I'm Jake Helbley. I'm Marketing Manager at Samsung for Digital Imaging.
Thanks, guys. So the first question, I think, is let's kick off with, let's talk about 4K video, because a lot of people out there might not know what we mean by 4K. You just hear the word video and think it's its own thing, but 4K video is quite a significant development in the history of enthusiast video, isn't it? I mean, Jay, why don't you just start talking to us, like, why should we care about 4K and what is it?
Because Samsung sells a lot of TVs, and 4K TVs are...
That was the wrong answer, okay.
Matt. Just like full HD was a driver for photo enthusiasts, videographers, everybody years ago, 3-4 years ago, 4K UHD production and capture is what we're seeing customers asking for today. They want to make that natural jump from full HD to 4K. Everyone's looking for 4K content. 4K TVs are out there. It's been a struggle, just like it was for full HD, for the full architecture and system to get there in terms of storage, in terms of editing, data management. The standards are there. In fact, the standards and the technology is well ahead in the televisions. All the televisions, the 4K TVs that are out this year support all the new codecs. They'll run H.265. They've got tremendous power. The piece that the market's been looking for now are the devices to build the content. And they're coming down in cost and up in performance, just like they did with the full HD paradigm.
So what is 4K compared to HD? I mean, just in layman's terms.
It's 4 times the resolution, right. 4 times the pixels, basically. And it's important for, I think, all of us to communicate to the market the difference between 4K and UHD. 4K is what you're seeing in the cinema. UHD is slightly less on the horizontal axis in terms of pixels, but it's essentially, it's up there. 3,800 pixels across versus 4,000 pixels across. But when people are talking 4K, they're talking the 4,000 across right. Cinema. In the TV market, we're talking UHD, which is the 3,800 pixels across. Essentially, they're interoperable. When you edit, there's no massive change in quality or shaving off pixels to get to the different aspect ratio.
And this is a new. I mean, this is hugely significant in the sense that this means for the first time that video that's accessible to an enthusiast has equivalent resolving power to the stills photography technology available to enthusiasts.
Well, yeah, and in driving that for years and years, the commercial market has been pushing for this. Commercial broadcast, the content owners, because as you're shooting 4K video, you can pull out 8 megapixel stills out of the stream and get still content that looks great in 8x10. It can look great even bigger. So if you look at any of the big sports leagues, as they convert to 4K video, that same content can be repurposed for everything, which is fantastic for them. For enthusiasts, similarly, you're shooting 4K video, you can pull out stills, wedding photographers, event photographers. It's truly a convergence of data that can be realistically and practically used for everything.
So Matt, Samsung has the NX1 here. I know Panasonic has the LX100, the GH4, the FZ1000. So 4K is obviously something you're putting a lot of effort in the stills photography space. I mean, why is that? Is that customer demand? Or?
Well, for us, 4K really obviously began in the GH4. And we were receiving requests from lower budget cinematographers to be able to use 4K because in particular for the commercial space, there's a lot of requests to shift over to 4K. And frankly, using a red epic for being able to do that, it's just cost prohibitive for a lot of people. So
This is for those who don't know, Red is the pro video manufacturer is putting out cameras now that can produce very high-res stills from 6K and
right. Red was the first company to really offer what was considered an affordable 4K or high-resolution solution for cinematography. So we decided to just completely break the mold and bring the price point substantially lower. And the goal was initially to reach out to independent filmmakers, independent film production, and provide them with a tool that they couldn't afford before. On top of that, it provides a lot of flexibility that photographers are used to, where you can punch in on a scene, which we couldn't do in 1080. Punch in, for those of you who don't know, is when I take a 4K image, but I know the final production is going to only be 1080. So I crop in up to 2-4 times closer, and that gives me the ability to digitally zoom, just like you would crop a photo, and I can go ahead and extract that 1080 image. Or I can pan with the subject in post. So instead of doing sort of a quirky, gimmicky, twist with my tripod and getting the skew that occurs, I can just shoot wide, and then in post I can go ahead and track that subject. But I think it's interesting because for photographers, it now provides them with the opportunity to extract still frames and use this in a way that they just haven't been able to use before. In a product like an FZ1000, you're going to get 30 frames per second of 4K video. That's a 30 frame per second burst shooting function.
Yes, let's talk about that, because years and years ago I was talking to to photojournalists who were taking video cameras out in the field, and they were taking HD, whatever they had, HD, nothing very good. It's 2 megapixel stills.
Right.
Even then, right, even then they were finding that they could take stills that they could use for media. And this must be going back 6 or 7 years. 4K is just a different league.
No, now you're getting, AP quality, sellable prints right off the video image. I think the one challenge really with shooting 4K video and then pulling frames is aspect ratio. I think that's a real challenge because you are starting with a 16:9 aspect ratio image. And for web use, it's perfectly acceptable. Most people have a 16:9 or 16:10 monitor, so it looks fine on the web. But if you're going to do something photo quality and you want to print it, you can do 180 DPI, 11:17 with an 8.3 megapixel image, but it needs to be 3:2 framed. It shouldn't be 16:9 framed. And so what we've done to help move forward this 4K photo function is to allow multiple aspect ratios for 4K video. So it's not just simply cropping out a 4:3 image out of the 4096 horizontal pixels or the 3840 vertical pixels. What we're actually doing is we're giving you an 8.3 megapixel file regardless of aspect ratio. So if you go with a 3:2 framing, it's actually going to have a higher number of pixels scanned. In fact, in 4:3, it's, I believe it's 2495 vertical versus 2 million pixels. So what you get is a proper 8.3 megapixel 4:3 or 3:2 framed image.
So you've put there's a feature I think called Photo 4K, is that right, in the LX100?
That's correct.
So you're trying to, how do you send that message to stills photographers? Like, don't disable the video button, this is useful.
Well, that's what I'm here for. The truth is that, with the LX100, we've begun to introduce it. We've done firmware updates to the GH4. We're doing a firmware update to the FZ1000 to add our 4K photo mode. I think the message ultimately is going to have to come organically from users. Mm-hmm. You can try to market this feature and try to get people excited about it, but until you have professionals who are out there actually shooting in this format and seeing the 8.3 megapixel 30 frame per second functionality they get, the first time you shoot your kid's soccer game and you're able to just pull those frames, 30 different frames, and just be able to pull that crystal clear sharp image of your kid kicking that soccer ball in for the first time, it's a level of burst photography that just hasn't existed before.
If I could jump in, I have a question about that because it's really cool. This whole idea of having 30 FPS burst rate or more to really capture that decisive moment for a photo. What sort of advancements are we seeing in video that would allow still photographers, the sort of stuff they use for still photography? For example, a video has this issue of rolling shutter effect, and hopefully faster readouts and global shutters can help with that. There's also the issue of focus, continuous focus in video, which is important for video, but also critically important for stills that you're going to extract, especially for type of photography I like to do with wedding photography, which is I really love using those f1.4 primes, and focus is critical. So could you comment a little bit on advancement in those technologies that will really allow still photographers to pull out stills from video?
Well, there's a lot of topics there.
Yeah.
So why don't we go ahead and begin with the autofocus functionality. Clearly, when we're dealing with larger sensor products, things like a GH4, like the NX1, up to the A7S with its larger full-frame sensor, as the sensor gets larger, depth of field gets much shallower, and it just creates a more complex algorithm that has to be produced for the camera to be able to properly focus in those situations. What Panasonic's trying to do to address this is with our depth from defocus system in the camera, which profiles the lens, and it looks at every basic, every focal length, every hyperfocal distance of that optic. We know what it looks like. It's blur profile at every one of those points. So we have a pretty good idea of where the lens needs to go, and this is our first generation with depth from defocus. So as we improve the algorithm, you're going to get better results and get better focus. I think it's important to note that our solution doesn't in any way take any diode area away from capturing a high gain image. So there are some solutions that are splitting a diode in half, and you're using two diodes in order to try to relive phase differential or phase difference autofocus, which is really kind of going backwards and where autofocus systems should be going, which is more toward contrast detecting AF, which is more accurate. And by splitting that diode, you're frankly cutting diode area, which means your sensitivity will suffer by doing that. We already get hit because we're a micro four thirds sensor, and people have this misconception about how sensitive the sensor can really be. We feel that the last thing we want to do is split the diode into two parts and then further reduce its sensitivity.
Okay. That's Canon's solution among others, isn't it?
There's a lot of companies. I don't think it's not fair just to pick on Canon in this regard.
The dual pixel AF is the most famous marketing, of that
Correct.
technology. The one thing that focus detection phase detection AF technology can do is predictive focusing and tracking focusing. I mean, how are you getting there with contrast detect AF?
We feel that we are moving very quickly into that realm of being able to be equal to phase differential, probably within the next 2 generations of product. It's really just input in the camera. It's how many different pieces of information you can give that camera to determine where the subject is, what the focus point is. By adding the profile of the lens into the equation, it's just another input of data that we now know about that image. So
just using more computation.
Right.
It's really cool. I mean, to be fair to some phase detection systems, though, when you do split the photodiode down the middle, I believe the Canon system has pixel binning to add up the signal when it actually takes the photo. So there are ways to work around it. You're absolutely right that there could be trade-offs, but there are also workarounds too, and you hope to see companies do that. And the other
bin, you're also then adding computational issues in the camera. You're adding potential is that a word? Potential issues with things like moire. Certainly increased occurrences of moire in the image. So, the goal from Panasonic is to speed up the image, speed up the autofocus system as much as possible, and do as little damage to the video image as you possibly can.
In my mind, though, also on phase detection on sensor, if you're using masked pixels, that definitely could have a trade-off in terms of you're getting less signal. But on sensor phase detection actually allows for, I think, a little more accuracy than having an entirely separate dedicated sensor with an entirely different light path. So there's some advantages to going on sensor in terms of phase detection, but doing it computationally is just awesome because you're just using more data, right? Exactly what you're saying.
I don't think in any of the paths any of the manufacturers are on, it's an either or. I mean, the phase detection sensor technologies are accelerating in their development at the most rapid pace in the history of photography, right? Or in just the last 6, 10, 12 months. Same with computing power in the cameras. So the computing engines are moving at a faster, more accelerated pace than they have for the last 5 years. In the last year and a half, more computing power has been poured into the cameras than in the last year. More computing power has been poured into the cameras than the last 4 years before that, all combined. So with advancements in autofocus, raw autofocus technology, computing power, all the algorithms that we're all putting in there, autofocus is going to be so extremely awesome in the next 2 generations of everybody's cameras that people will wonder how they survived without it before.
I can't wait to see it in smaller cameras without total separate dedicated systems. And while we're on the subject of focus, I really would like to hear from Lytro. So.
Well, I was letting the conversation flow because it's an interesting illustration of the amount of energy goes into to solve a problem that a different technology would not even have, right? So Lytro makes light field cameras, right? So light field is this new actually it's not that new, but a new implementation of a theory where instead of capturing the focus plane, which is what the sensor does or film used to do, we capture the rays of light in the scene. And then computationally, we can render an image, literally render, meaning I'm borrowing a word from computer graphics rather than photography. We render an image based on 3-dimensional data that can simulate any focal plane. We can simulate tilt shift camera. We can simulate any lens. We can simulate any aperture. We can simulate any focus. So in the past, it has been associated with sort of a gimmicky idea of just you can refocus. But the power is so much greater because you have a 3-dimensional model of the entire scene. And all of these challenges that, which are ingenious in how they're being solved in traditional cameras. The technology that are here are amazing, but they're solving to a problem that doesn't exist when you deal with light field, where you can literally, after the fact, set the exact aperture. Focus, when you take a picture with light field camera, you really have to think about what do you want to capture. You focus on the composition rather than the technique. It's talking to the artist rather than the technician, which is in all of us, right? It's that split mind. And we want to enable the artist to really focus on the best composition possible, and then after the fact, find the right focus for that moment. And what's interesting, once you watch photographers use the product, is that they attest themselves that after the fact, in post-production, they were able to generate photos that they were never able to generate, they never thought were in the shot. Sort of, when you suddenly change perspective and you change the focus and you have a more shallow depth of field, you suddenly discover things that you could tell a different story that wasn't there before. And now you start animating it and you just change what a picture, what photography is, which ties back to 4K. The big change in 4K, other than the technology and the ability to extract still images, which is phenomenal, it's the fact that the medium, the display medium, is suddenly high quality enough to be considered the print. The race, the megapixel race that we've been part of, was driven by the need to differentiate, to be better, to keep on justifying the scale, and to always say we can have higher quality prints. It's going away, and it's going away because of 4K. So suddenly the measurement is what can you display on a 4K display. After that, there will be additional 6K and so on, but suddenly the medium of consumption will change the discussion about what a camera should produce. And I think that's exciting, that's thrilling.
The analogy I use with people who aren't aware of Lytro is, to photographers who aren't aware of Lytro is, remember the first time someone explained shooting RAW to you? Right? You take a picture and you messed it up, but you take the RAW file and you can
save it
change
with a
the
dial.
Exposure and you can change the white balance and suddenly there it is. You didn't mess up anymore, you fixed it. And light field imaging allows you to do that with composition, but composition in 3 dimensions.
Right, and this is the largest obstacle that we have right now as a company. We're trying to figure out how can we help photographers transition the way they think. We've been tracking our ambassador program. We've been working with amazing photographers throughout the world, and we've been tracking the transition that happens in how they think. We interview them before, we interview them during, we observe how they work, and then later on. Yesterday I met with this great photographer from Germany, and he was explaining, it was funny, he said, I'm actually quoting him, he said, when I held it for the first time, I felt comfortable because it feels familiar. It's a professional camera. And then I started using it, I said, why do I need all these cameras, all these buttons? I don't need to control anything. I just want to slide my finger, and after that, in a computer, set whatever I want. That's all I want. Which definitely just changes the way you think of it. And the transition from composing 2D and taking lots of pictures, right? The burst mode is a way of compensating for the fact that you may not get the right shot. Right? You have the wedding, it's happening in real time. You're not going to get that moment again. You better get it right. Well, once you shoot with a light field camera, you no longer have that anxiety about did I get the shot. You need to think, did I get the composition? And the composition is in 3D. And that takes a transition to think about it. What do you have in the foreground? What do you have in the midground? What do you have in the background? Is it well exposed for that? So there's still a lot to evolve in this technology, but it just changes the conversation what you're trying to fix.
One thing I like to always say is that when we see some of these new technologies coming out, it's really about technology getting out of the way so you can focus on the art. So you can open up creative opportunities by getting the technology out of the way. And so that's really one of the things that's really exciting to me about this stuff, because there are things that you can't change after the fact. You can't really change, the lighting, or you can only change to a certain extent the composition. So you're focusing on these things at the time of capture, or just capturing the decisive moment. It's a very noble goal to be able to open up, the freedom of adjusting all these things after the fact, or fixing them after the fact, or seeing things you wouldn't have even seen at the time of capture after the fact. So that's really cool. One thing that I think is amazing about this is when you consider that it's a pretty light camera. It's a 30 to 250 equivalent lens, f2 all the way. When you pull this into the software and you use the aperture slider to dial that aperture back down to f1, it ends up being a 30 to 250 f2.7 equivalent.
Yeah.
If you imagine a 30 to 250 f2.7 equivalent full-frame lens, it would not weigh this little.
That's right. And what's interesting about its optics here, and by the way, later on we have a session where we'll be demonstrating that software. But what's interesting here is that this lens, this optics, which is light field optics, doesn't actually form a picture. It doesn't create a focused image. It keeps the image completely blurred so we can capture 40 million rays of light, their exact angle, their exact intensity, the color values, and we really get 40 million rays of light. So we talked about computation power. This camera can process 40 million rays of light. These are not individual necessarily just pixels, which are the focus light, but the actual information about it, and process them. We often say that light-ray is currently bound by simply what Silicon Valley can give us. We're bound by computation power, bound by amount of memory, by density of sensors, and we as ambassadors of light field photography can choose. We can choose what we invent. We can choose what to accelerate by partnering, and what we just have to sit on the sideline and wait until it gets there.